Dear students, today we will be discussing three equations of the motions, and out of these three equations, one of the equation every time will come in your exam. So let's do it. First equation is Vf is equal to Vi plus At. Second one, S is equal to Vit plus half At square. And third is 2As is equal to Vf square minus Vi square. You can see with the help of these three equations, we can find final velocity, we can find initial velocity, we can find acceleration, we can find time and distance as well. So let's start with the first equation. So we do have a graph that is called time and speed graph or speed and time graph, right? So x-axis we are having time and y-axis we are having speed. So that's why we say speed time graph. Here the initial position we call it origin, right? The value of the speed is 0 here. In the pair of order, the first one value is for speed and second one for the time. So time is also 0 and speed is also 0. Whenever body is moving up, speed is increasing, right? And time is also increasing. So if your object starts moving from 0 to A, so that will be our initial velocity. So OA is our initial velocity. OA length is equal to DC length as well. So we can say OA or we can say DC. So this one distance that is DC or this one distance that is OA actually our initial velocity, right? And then from this one point to up there, that is point B actually. So from D to B we are having final velocity, right? So this one is initial velocity from D to C and from D to B is our final velocity. So if we want to know the distance of this one BC, total velocity that is Vf, and subtract this one length here, we will left with this one length. So this one BC length is equal to Vf minus Vi. So if Vf the final velocity and subtracted this one the total length and subtracted this one, we will left with this one length. So BC actually is equal to Vf minus Vi. Alright, okay. Here it is written that BD your final velocity, that BD is your final velocity, and then DC is your initial velocity. So DC is your initial velocity, right? And OD is your time, O, right? And D is your time, in which time your velocity is increasing, right? And you know that, student, that OD and AC both length are equal, right? And both lengths, so that's why we say OD is T, and OD and AC both are equal and both are equal to T, right? So if this one length is BD, that is final velocity, minus initial velocity, that is BC. So here BD minus BC is equal to BC. This one BC is our difference. So write the value, BD is equal to Vf minus Vi is equal to BC. Alright, now the slope of the line, this one line, that A and B is actually your acceleration, right? So the slope of the line AB, slope of the line is equal to BC or AC. So our BC is equal to this one, that is your y-axis, and then our x-axis is equal to AC. So we calculate the slope change in y-axis, right, divided by change in x-axis. So BC over AC, right? So our slope is equal to AB is equal to, we call that slope is equal to A, and slope of the line is actually your acceleration. So slope of the line is called acceleration. That is equal to BC value, here it is given. BC value is BD minus BC, BD minus BC, right, divided by AC, and AC actually your OD, because AC and OD same, that is T. After adding the value, we are having Vf minus Vi. This T is dividing here. If you will take that t and just shift up to the left side of the equal, then it will get up there with inverse operation, and then it is dividing here, it will multiply with a. So a t is equal to Vf minus Vi, right? So that equation a t is equal to Vf minus Vi actually our first equation. Let's rearrange it. We will rearrange it to find the final velocity. This Vi actually minus, when it will go to that side, it will get positive. So at plus Vi is equal to Vf. So Vf this side and at plus Vi are this side. So you can shift it like that. So Vf will get this side and at plus Vi will get this side. You can write Vi first, you can write at afterwards, because both are positive. So this one is our first equation of motion, Vf minus Vi plus at. That first equation is taken with the help of graphs. So with the help of graph we can calculate it. And if we have the definition of acceleration, you know the acceleration is change in velocity divided by time, and change we calculate the final velocity minus initial velocity, that is equal to change in velocity. Time taken is written same, right? Final velocity is written Vf minus Vi, right? And then t is there. So this t will go that side, it will multiply, so we will get a t Vf minus Vi. Again, this one negative value will go that side, it will get positive. A t is equal to Vi is equal to Vf. So Vf you can shift like that. So Vf will get that side and these both will get that side. So first we will write Vi plus At. With the definition of acceleration, we can have first equation of motion like that. So see you with the second equation of the motion.